Now in this course we need to be able to identify the domain and the range of a function, or a relation, which I've just added in there to my notes. Now the domain is just the set of all possible x coordinates that you could have, and the range is just the set of all possible y coordinates. So we can find domain and range most easily if we've already been able to graph something, or if we've already been given a graph, because we can literally read the domain and range off the graph. Now an important thing to note is these little arrows that you'll see when things are graphed, and that really highlights that things just go onwards and upwards perhaps, or downwards and in this direction. So look for those arrows, because some graphs won't have arrows. They'll actually stop and they'll have endpoints. We've already seen intervals that have endpoints, and we've noted that a coloured in circle means that that point is part of the graph or part of the line, and an open circle indicates that that point is not part of the graph, but everything up to it would be part of it. So reading these off the graph here, if we say that x can be anything, then the way of explaining the domain is to say the domain is all real x. Now, why all real x? Well, there are such things as numbers that are not real, imaginary numbers, and you'll look at those if you study Extension 2 maths or maths in more detail at university. But for now, let's just be happy with the fact that we are going to say all real x, meaning all real numbers are possible. Now, if x can be anything and it's equal to y, it makes sense that y can also be anything. And we write that mathematically by saying the range is all real y. For our parabola here, we've got the parabola y equals x squared minus 1. So that's just a basic parabola that's been shifted down 1 unit. So we can see here that it's going through the y-axis at -1, and that point is included in the graph. Now we can see that x could be anything because these arrows here show that it's going onwards and upwards like this. After all, you can also take any number and square it and then subtract 1. So there's no reason to think that x has any real limitations. So we'd say that the domain is, again, all real x. The range, though, we can clearly see that this graph has a low point, and from there it's always going upwards. So there are never going to be any y values down here lower than -1. So we explain that by saying the range is y is greater than or equal to -1, because that's its low point, all values above. Now this graph over here is a bit unusual. It's got endpoints. One of them is included, one isn't, and we can see the points, -3, 2, -2, and 3, 2. So we'd say here that the domain is only x values between -3 and 3. So reading it acrossways, x must be between those 2 points. And I've put a x must be greater than or equal to -3 on this side, whereas this one doesn't have the equal sign. It's just x has to be less than 3 because that point there is not included. And similarly, the range, if we're looking at what y values are possible, we can only have y values that are in between -2 and 2, with the bottom one being included in our range and the top one not included.